This is part 3 of Solving Quadratic Equations by Graphing. We are on example 6, Modeling Real Life. All right, so the table shows the recorded temperatures in degrees Fahrenheit for a portion of the day. Use technology to find a quadratic model for the data, then determine whether the model is a good fit. At what times during the day is the temperature 77 degrees? So you can see here's the table. 6 a.m. we're at 58, 8, 68, 10 a.m. 76, 12 noon, 82 degrees, 2, 84, 4 is 81, and 6 p.m. is 75 degrees. All right, so it says use technology to find a quadratic model. All right, so the first thing we're going to do, make sure your calculator is cleared out. So do second plus 712. Second plus 712. That will clear your memory. It clears out the tables, the graphs, anything that may be set in here, it will clear it out. Once you do that, you can click on Stat, Edit, and it lets you enter your table in the calculator. All right, so we're going to enter our time as everything after 12 midnight. So 6 would be 6, and then we've got 8, we've got 10, we've got 12 noon is 12 hours after midnight, and then 2 p.m. So instead of putting 2, we need to put 14 because this is 14 hours after midnight. And then 4 p.m. would be 16 hours after midnight, and 6 p.m. would be 18 hours. Try that again. 18 hours after midnight. All right, so make sure you've got everything typed in correctly. All right, and then enter the temperatures in L2. All right, I always like to double check and make sure that what I typed in is correct very quickly. To do that, if you have the wrong information in the calculator, you cannot get the correct answer from your calculator. So that should always resonate as a true statement. All right, so it says use technology to find a quadratic model. Then determine whether the model is a good fit. All right, so we're going to ask our calculator to write a model and then determine if it is a good fit or not. All right, so the first thing I want to do is go to second 0, which is catalog, and we want to turn on our diagnostics. You probably can hit D and it'll jump down to diagnostics, or you can just scroll down through your list. It shows you everything that is in. It's a catalog of every function in the calculator. So there's a lot of information in here. If you want to just play around one day and see what all the functions are offered, this would be a good place to do that in the catalog. Right now we want diagnostics on. There's a diagnostics off, diagnostics on. If I hit diagnostics on, I have to hit it twice. I have to hit enter twice. It has to say done. What this does is turn on your R or your R squared, which is your correlation coefficient. That tells you if your model is a good fit or not. All right, now once that is turned on, we can go back to Stat. We already hit Edit and put our table of values in there, so those are in there. Now we're going to go to Calculate. So the question says find a quadratic model. So we're going to go to Quad Regression, number 5. It's pulling from L1, L2, and we want it to calculate. All right, so you can see here, negative 0.43, that would be my x squared value, 11.7, and we can round this up to 2. So let's go ahead and write our function down. So we can say f of x, we can say y equals, however you want to put it. That was -0.43 x squared plus 11.7, and then plus 2. So that's an equation. Of course, these numbers are rounded just a tad bit, but that's an equation written by your calculator based on the points from this table. All right, if you want to see what the points from your table look like, go to do second Y, which is your stat plot, and you want to turn on your stat plot. All right, so this is going to give us a normal 10 by 10. You can see that the numbers we put in here, these numbers go by hours, so this would be up to 24. We only went up to 18, so depends on what values you want to see. Let's put -2. We don't need any negative numbers for time, but we have to put in a negative, so we're going to make that very small, close to 0. The maximum, again, is 18. We can actually go a little higher than that. Let's go up to 20. All right, and then our Y values, again, we don't need really any Y values, so we'll just make that -2. And then our X maximum has to be above 84. Let's put 90. All right, and we don't need 90 little tick marks there, so let's make this a scale of 10. So these are going to go by 10s. And then hit graph. So when I make this a scale of 10, this is like 10, 20, 30, 40, 50 degrees, so on. So you can see the shape of this. It does look like a parabola or a quadratic function. So looking at this, it says, is it a good fit? So if we went to our function and it said 0.99, so our R was 0.99, or R squared. I can't remember which one it had. Let's see. Let's go to stat, calculate 5. All right, so it had R squared equals 0.99. The closer this is to 1, the better model it is. So this is a very good fit. So it's a very good fit. All right, if we want to go one step further in determining whether the model is a good fit or not, I like to look at the function on top of the scatter plot. So if you go to Y equals, and we go to vars, number 5, stat, come over to equation, and hit enter, what it did was copy this equation into this, like it didn't even round it. It copied the exact equation into that line there. All right, or you could type the line in, or you could type this equation in, either one. You hit graph. You can see that it goes through those points exactly. So that's awesome. All right, so let's try it the other way. So let's hit clear. If you don't want to do those steps, you can just type in the function that we found. Negative, well, let me try that again. Negative 0.43 x squared plus 11.7 x plus 2, and hit graph. This is our rounded version of what the calculator said. So it should look very much the same. And you can see that it does. It's going pretty close to those points. The exact equation was a little bit higher. It was a little bit more exact. We know that we rounded this, so it's going to be off just a little bit. But when it says at what, we can still say it's a very good fit. B part says, at what times during the day is the temperature 77 degrees? Okay, so to determine that, let's write another function that says y equals 77. So that's saying we're going to have this function. When does it equal this function? So we want to find the intersection point of these two. Okay, so we want to find this intersection point and this intersection point. When these two intersect, that's when it's 77 degrees, and then we can determine what time of day that is. All right, so let's go to second trace. And let's do intersection. All right, I'm going to do intersection on the first curve. Let's do enter again. And it's going to say about 10.3. Okay, we'll come back to what that means in a minute. So about 10.3. And then we need to find the other curve, the other intersection. So we're going to go second trace again. We're going to calculate intersect again. And this time we want the intersection on the other side. This is where it represents 77 degrees when the temperature is coming down in the afternoon. All right, so it's going to find the intersection of those two, and it says about, we're going to say 16.9. All right, so remember these is hours. In our table, we went to 12, and then past 12, we went 14, 16, 18. So you know that 16 is going to be between 4 and 5 o'clock. So let's determine what this means as time. So 10.3, so like 10.33, 33% of an hour. There are 60 minutes in an hour. So this is going to represent about 10:20 a.m. About 10:20 a.m. it's going to be 77 degrees. All right, and 16.9. All right, so we know 16 is 4 p.m., but for what? Sorry, I've got lots of stuff going on here. So 4 something p.m. All right, so how do we know? So this says 0.9. So what is 0.9 of an hour? So we're going to do 0.9 times 60 minutes, because there's 60 minutes in an hour, and that's going to be 54. So about 4:54 p.m. it's going to be 77 degrees. So we can say the temperature is 77 degrees at about 10:20 a.m. and again about 4:54 p.m. All right. Hopefully you get familiar with your TI-84 and you learn how to use it, because again it has great functions that can do a lot of good stuff and help you find equations and all kinds of things using that calculator. So if you have any questions, please let me know. Have a good day.